Hi, welcome everyone. Thanks for tuning in. I'm Raghu Chandra, CTO of Cognizant AWS Business Group. I've had the good fortune to consult a large number of enterprises globally on their cloud transformation journeys, and I've had the opportunity to experience and learn the evolving best practices for sustained cloud transformation programs. We have learned that large enterprises with several lines of businesses have struggled to operate with a centralized CCoE, and we have come to realize that some simple tools based on event-based architectures can provide autonomy, self-service, and agility to line of businesses and application teams while ensuring governance. In this session, I am excited to share about shared services platforms and design patterns for federated cloud centers of excellence. First, we're going to talk about the purpose of a CCoE. Then, we're going to look how a CCoE can become a bottleneck. We will look at two simple examples of automation that builds velocity to cloud transformation programs. Providing executive support, establishing a cloud center of excellence, educating and training staff, creating a culture of experimentation, a hybrid cloud operating model, and implementing a cloud-first policy are some of the foundational best practices for a sustained cloud journey that meets the core purpose and business drivers of an enterprise. Talking about the cloud center of excellence, enterprises establish a CCoE to spearhead their cloud journeys with goals of agility, reliability, scalability, and leaner operating model. Early research and investments have gone into studying how the CCoE teams are put together that has the right mix of working relationships, operational rigor, and innovation culture. Effective CCoE teams start small. They develop an approach for scaling cloud adoption and can become the fulcrum by which an enterprise transforms itself with cloud services. Now let us level set the CCoE's core purpose and objectives. Common design tenets that guide the function of a successful CCoE include the evolutionary nature of CCoE structure, that CCoE is not a static organization and it changes as the cloud adoption of an organization improves or accelerates. Product mindset of delivering cloud services to development teams and treating developers and application owners as customers. Building or transforming the culture of delivering services and being intentional about organizational change management. Building a high-frequency change organization and embracing change as normal culture. Changes in application architecture and business direction should be expected. And last but not the least, operating model design and change is an important business outcome of CCoE. A CCoE is comprised of two functional pillars, the Cloud Business Office and Cloud Engineering. The Cloud Business Office ensures that the cloud services meet the needs of your internal customers, your application teams, either your line of business applications or IT applications. As I said earlier, enterprises should adopt a customer-centric model towards development teams and application owners. But this is often a radical shift for most organizations. This consideration is often lost in many cloud centers of excellence as days go by. The CBO owns functions such as organization change management, stakeholder requirements, governance, and cost optimization. It develops user requirements and onboard new applications and users onto the cloud. It also handles partner management, internal evangelization, communications, and updates to users and executive sponsors. The Cloud Engineering Group, on the other hand, owns functions such as infrastructure automation, operational tools and processes, security tooling and controls, and migration landing zones. They optimize the speed at which a business unit can access cloud resources and optimize usage patterns. The Cloud Engineering Group thus focuses on performance, availability, and security. Although the intent and desired outcomes from these groups is aligned with the recommended best practices of governing a high-velocity cloud transformation journey, centralized cloud centers of excellence can become a bottleneck in large organizations with several lines of businesses. Some of the common reasons are the CCoE retains the on-premises mindset. It becomes a single point of validation for all application deployments. It cannot keep up with the new service demand. It becomes a permanent fixture than a transitional one. And it often takes on a gatekeeper and an auditor role. We have found that more than 80% of CCoE tasks are spent in validating images on onboarding new applications and new cloud services. So, you are left with the option of giving more control to application teams, like self-service catalog. But you miss out on best practices of ensuring security, like volume encryption, security group, access log and key management, and best practices like placement policies. The solution is to bring governance and agility to SelfService Platform that will take care of all best practices. And the SelfService Platform removes heavy lifting from the CCoE. It lets users build their own environments. It defines constraints on which AWS resources users can deploy. And the platform integrates the application CI/CD pipelines for self-service deployment. And the platform automates validation of images and new application onboarding. Now, let us look at two simple examples of self-service, which together improves CCoE agility by more than 300%. First, let us look at automation of validation of latest operating system, middleware, and application images. In this architecture, base operating system images are created and verified and released by the Cloud Center of Excellence to a container registry, which is Amazon ECR. Once new images are available, the image ID is updated in the parameter store. Every middleware that is using the operating system image will subscribe to this key. All subscribers will get notification that the operating system image key is updated through a CloudWatch event. The Lambda functions, listening to these CloudWatch events, get triggered and then uses Amazon Code Build to pull the latest operating system images from ECR and recreates new middleware with the latest operating system images. These images will be checked into ECR. Now every application that uses these middleware images will be notified through a CloudWatch event. Your Lambda function again will be triggered and new application images are created using code build and checked into Amazon ECR, and Amazon Code Deploy is called to deploy these images onto ECS. Now the test suites are triggered and run through a CloudWatch event. This simple event-based architecture automates one of the most time-consuming tasks of a Cloud Center of Excellence. And we have seen huge improvement in agility in a global organization with several lines of businesses and hundreds of applications in active development. Now, let us look at onboarding new applications. This simple architecture contains three major functional blocks: configuration engine, infrastructure as a code generator, and infrastructure deployment engine. First, let's look at the configuration engine. Here, application owners enter application-specific data like operating system, middleware, CPU, memory and storage requirements, ports, and how many copies of applications need to run to manage the load. Next, the infrastructure generator. This generator converts the user-provided data from the configuration engine into meaningful JSON data. Now, the AWS config converts JSON data to AWS-specific config data. For example, it converts operating system to AMI, memory and CPU to instance type, region to VPCs, application accessibility to internal or external load balancers, and ports to load balancer listeners. Now, the deployment engine converts the AWS configuration JSON from the infrastructure as a code generator to a dynamic CloudFormation template using CloudFormation Development Kit, or Terraform and checks in the code to source code repository. Based on the template, an event will be published and the subscribers get triggered to scan the code. If the checked-in code is Terraform, a specific scanning tools can be used, or you can use CF and Guard for CloudFormation. If the scan is successful, deployment engine gets started and deploys the infrastructure. Now I'm going to show you some sample screens from the platform which provides self-service. First is onboarding an application. Next is setting up global application configuration. Next, you configure the environment. You are providing more granular control. And then you have a one-click deployment. As said earlier, simple shared service platforms like this can improve organizational agility by more than 300% in terms of migration velocity and application deployments, and ensure that the CCoE focuses on innovation and governance, and at the same time build a self-sustaining cloud transformation organization. Again, thank you for tuning in and listening in. We'll be happy to answer questions. We are immensely excited to see how you have innovated with your cloud centers of excellence and drove high-velocity enterprise cloud transformation. Thank you.